Historically, it's not hard to build a home. How do you do that on mass scale? How do you do it in a more cost-effective way? That's the hard part. We design, develop, and deploy mobile microfactories. They can do about 200 single-family homes a year. Today in the US, it's about $185 a foot to build a home. We can deliver homes today with a factory nearby at about $100 a foot.
I'm so excited to talk to you guys. I think that one of the coolest things about this company is that it adheres to Elon's vision of the world with his company. So often when Elon talks about his companies, he says, yeah, sure, Tesla's building cars, sure, SpaceX is building rockets, but the real product is the factory that builds the rockets, the factory that builds the cars. And so for you guys, it really, to me, it seems like your product is the factory that builds the homes. Is that a fair way to say what you guys are building?
100%. Everything was built day one with scale in mind. After all, our goal is 275 mobile microfactories out in the wild. There's no way to do that not having the factory be the product. Oleg can go more into this because day one he was thinking about how it's all the system. And Oleg, I mean, you did send a bunch of books to Elon when you wrote your book, I think so.
Yeah, well, I'm 100% agree with Alex. And in the beginning of the project, we began to think how we'll scale the business. And that's why everything that we're doing, we try to fit to this process, how we will scale and how we'll just open new factory. And that's why, if we change something, we change the machines, we change the kit parts and so on. But all of that stuff is just lead by this idea.
Totally. Because, I mean, at the end of the day, you guys are building homes. That's like the thing that's coming out of the factory. And the thing that if you weren't building homes, then you would make no revenue. It's not just you can build a factory and then, that had to do nothing, obviously. Like the point of it is to build homes. And so one way to build a better home is to basically do it yourself. Like you two are out in the field, hammering away, like whatever, installing the things yourselves, just like we're like working really hard like that. But obviously, like that's not something that's going to scale to a venture meaningful business. Like ultimately, I think like after looking into it, I think maybe the simplest way to describe what you guys are doing is that you're building better tools for home builders, right? Like in theory, your tool could be just like a magical screwdriver or something that's like the greatest installation tool that makes it so much easier and faster and cheaper. Of course, you're not building magical screwdrivers, you're building other stuff. But would you mind telling us just like what those things are, very high level? Like what are those tools that are helping home builders build so much easier?
Yeah, I think you hit it on the nail. I mean, anyone can build a home. Historically, it's not hard to build a home. There's lots of folks that are fragmented out there across the world that build homes. The harder part is how do you make a tool, like you said, which for us is our product, which is a mobile microfactory to enable home building with a lot less skilled labor, which in turn reduces cost and generally reduces the labor hours required to build a home. How do you do that on mass scale? How do you do it in a more cost-effective way? That's the hard part. That's why we had to think about the system. The byproduct, the homes, that's just, like I said, a byproduct of that system. Our tool, like you say, is a mobile microfactory. It is what exactly I'm sure your viewers are imagining it to be. It's literally a containerized solution. We bring that wherever there's demand. We erect it in a matter of weeks. So literally shove a bunch of our proprietary machines, which are stations that I'll describe what they do, but we shove them into containers, inflate a mnemonic structure, which Oleg can show you. Our R&D center is in one of them, so you can give a quick tour in a bit. And we basically create a perimeter that forms a temporary decentralized manufacturing facility. Within it, we do one of two things. One, we make things from scratch, so things like frames or windows or helical piers. So certain elements of a home that we take a raw input, turn it into a finished good. And then other things that are a bit more basic and off the shelf, like the sheetrock behind your wall or my wall, or PEX pipes that form the plumbing, or wires that we're pre-cutting, prepping. But the idea is we do two of those things, we package them into stages, basically everything that a home is comprised of, and get to send that down the street because our factories are proximate to where the actual construction is happening. And then we get to assemble those kit of parts into finished homes. But our product is the entire system, and its byproduct are the finished homes.
I can add, we can look on our job a little bit different angle. You explained that we come up with a new screwdriver, but still the GC, they have the same process. But in our case, we provide to them also the different process, how to do the same job. And to this process, we provide to them all the tools. But this is vice versa tools that they're using, right? It's a software, it's a machines, and so on. And I can explain that. The construction process is a project management process where there is one guy who controls the construction, who push everybody, and if something will happen wrong in this waterfall, everything will crumble. In manufacturing, the process set up in a little different way, where there is a conveyor, and in this conveyor, one process controls another one, and that's why it's more stable stuff. And that's why we set up the Cuby as a manufacturing conveyor, starting from the materials and design, and finishing with assembling. That's why assembling team, it's also part of the conveyor. It's employees of the factories. That's why all of this process is absolutely different now. Now the construction is manufacturing.
Yeah, totally. Which is a unique way to think about home building, right? Because normally you don't think about home building as like a factory process like Henry Ford or something. You're not thinking of it as churning out many homes.
But the interesting thing is there's parameters. It's almost tough to call what we're doing what Henry Ford did with cars, because if you recall, right, Henry Ford said, you can have any car you want as long as it's black and it's the Model T or whatever. In home building, it's a bit different because folks require customization. Those folks being end consumers, developers, etc., they require different sizes of homes, layouts, finishes. Not all the same homes work for the same lot in which you're placing the home. So our system, it's pretty dynamic in the sense that we needed to innovate within parameters that exist. Those parameters are regulatory. Those parameters are around customization. So there's, I know you're in space. That's really your domain expertise in space. You get to kind of go from A to B in any engineering possible solution you need to, just to make sure it works. Here we're confined by a box, and that box has so many parameters from lenders to regulators that we had to innovate within it. So we can't just go full 180. So some of the principles that we have in this space is, okay, decentralized manufacturing, that's one approach, and we'll get into why that needs to be the case. But our second and third pillars are around familiarity of end product, meaning we can't over-engineer a home. It has to be the same home that's been built before. And two, cost. So those two things are very, very important, and those are really main principles for us.
What's the simplest way that you could describe where technology enters the process, basically? So think about it as at one end is like the dumbest home building technology in the world. Like we're using hammers and nails and like printed out blueprints, and it just like the one guy has to know how to interpret all the blueprints. On the other end is like tech utopia home building. Like I personally, me, Christian, could go like build a home tomorrow just myself. Like where do you guys fall? I'm sure this is different for different parts of the process, but like what are the tech-enabled pieces of what you guys are building?
It's interesting because in theory, you, Christian, could go build a home tomorrow. Homes are not a very sophisticated thing. They're actually not as high quality as people think they are. There's lots of mistakes and lots of standard deviation worth of mistakes, etc. It's really a function of the labor hours it would take you. So you would be building your home for 3 years probably, right? Technology hasn't really evolved in the construction sector. In fact, construction workers today are less productive than they were in the 1970s. It's a function of a lot of things. It's mainly probably a function of the aging demographic in the space. Average construction sites are 40 to 50 years old, right? There's it's a very labor intensive field. So we've gotten less productive, and there is also physically less hands that are capable of building the amount we need to build. So for us, technology solves the skilled labor piece that's depleting and the labor hours required, which helps bring down cost because it physically takes less time. I would say our IP is layered in I'd say like 3.5 steps. One, it's the factory itself. So 50% of the machines inside the factory we make ourselves. They're proprietary to us, and some of them are pretty complicated. Some of them are all like getting gray hair over some of them. And some of them are simple, like certain shelving systems that didn't exist in the market, but help our lean manufacturing process specifically. So the factory itself is, there's IP around it. Even things as simple as shoving machines into containers, that's hard. You got to make 4 dozen custom shipping containers for every factory. You have to certify them because you have to ship them globally. Once you change the structural integrity of a container, you can no longer insure it. So like even little things like that, you chop a solution off and it's like a Medusa's head. There's 10 other things you got to solve. The second layer I would say is the end product, so the kit of parts that go into the home. Yes, they're basic. Yes, they're compliant, but there's still certain nuances to them that allow them to be assembled on site in a quick manner. The third is around software. So our entire factory, entire processes it's all our software. There's no software off the shelf. So there's an entire OS to running the factory and the processes. And the other step, I said 3.5, that's really know-how. It's hard to do what we're doing. That's why, when it comes to IP, it's almost hard to believe in IP, because if someone can do this, we should probably go work for them. I know that's Oleg's number one belief. But relative to traditional construction, traditional construction is swinging a hammer, a very skilled carpenter, basically doing a bunch of steps manually. And each time it's a non-repeatable step, unlike manufacturing. So you could have home A and home B be the same exact home, built by the same crew, the same budget, the same design, but those two homes will come out different because every process is a one-off. What we're trying to do with off-the-shelf technology, some proprietary technology, but it's mostly Toyota's production system at play, is to create a repeatable process, a quality repeatable process that debundles from skilled labor. Maybe you want to add from how you feel about the technological piece relative to traditional construction.
Sure.
Maybe on the software side specifically.
Well, first of all, when you have project management system, you need to use professional guys. And how we can determine that the guy is professional? He know what to do, and he have skill how to do it with a high quality. We solved this problem with unskilled labor. I explain you how. The first of them, with exact distributed software and a lot of construction plus an Unreal Engine, we exactly say unskilled labor what he need to do right now and automatically generate to him video instruction what he need to do to take this piece and put it there. After that, there is an education system that we educate him to use the screwdriver and so on, and he passed through the education testing system, and only after that the system gives him the task to do that. Regarding, to do quality job. All the kit of parts that we design in such manner that the guy have no chance to make a mistake. It's only click system and the design of all of this kit of parts this way that unskilled labor need to install it, and the system automatically install it in that place where it should be installed. That's why all the job, when we can't digitally determine the quality of the job, we take off of the process. For example, to paint the wall. How you can determine the quality how you paint the wall? It's very relative. One guy tell you that you painted good, another one tell that you painted bad. In this way, we have finishes panels that already produce in the factory with the click systems that you just glue on to put it on the wall, click it, and that's it. And that's why all the jobs that we're doing in our system, we use this philosophy. And in this case, we can take anybody from the street, unskilled labor guy. He passed through our testing, technology, tools, machines, and so on. And after that, he go to the construction site on the factory, and the system gives him exact task what he need to do right now. I will explain a little bit more. The construction consists of 30 stages. Each stages, 35 stages. The first stage is foundation. The second stage is, for example, framing, walls, and so on. We have a software. In this software, we design the house, and the system automatically divide all the job and all the kit of parts that we need to produce based on the stages, and gives the task to the factory what the factory need to produce to exact house that we need to build, and exact, stages and packs and kit of parts that we need to produce and deliver to them. After that, Unreal Engine system automatically, based on this plan, generate the video instruction to each role in each stage, because we write the scenario to each stage, and the system generate the video based on this scenario, what they need to do, what they need to take, and where they need to put. And based on that, the system control by the plan, it's like an Uber for the worker. It's a software where the system gives a distributed task to all the participants of the construction site, what they need to do right now. And it's looking like that. You take the phone, push the button, and there is a task. Next 2 hours, you need to do this. and there is exact video what he need to do. When you finish, you push the button, and the system give the task to his master, to his leader. He need to check, and he also have the scenario of how he can check it. He pushes the button, and only after that the system begin to generate another task. That's why this is very complicated algorithm that help us to distribute and to teach a lot of people and to involve them as fast as possible to our approach.
Oleg is being humble. It's easy when it's one home, but imagine 20 different homes within a 150-mile radius of each mobile microfactory, and it's all happening at the same time at different stages.
Plus, all of them have different designs, but all the designs consist of final numbers of kit of parts. We have final numbers of kit of parts, and based on the shape and the size of the building, we have different numbers of each of them. And based on that, automatically generate video instruction, task to manufacturing, task to assemble, task to instruction, or checking the stages, and so on.
Wow, I love that. First of all, I love that it's Unreal Engine. Like, that is so cool. And it's, if people haven't actually played around in Unreal Engine, they might not get it. It is such a powerful tool for so much more than just like gaming.
100%. And we use also Unreal Engine for the additional reality, because when we give the task to the skilled labor, unskilled labor, for the next 2 hours, what you need to do on the phone, he pushes the button and he exactly see where he need to install this or that stuff, and he, in this additional reality, he point out where he installed, what part he installed already, and when he's ready, the system know that this stuff is already installed, and it's give another task, and in this additional reality, this part is ready for him. And for the new one, he see a new part that he need to install this.
The analogy goes like this of what we've done and why it's amazing. Imagine you bought an IKEA table. It's a yellow IKEA table, and it came with a set level of instructions. But now imagine what would need to happen to those instructions if that table constantly changed from its size to the amount of legs it has to the colors. So the assembly instructions would need to dynamically change to correspond to that. So we've created a dynamically changing instruction manual for every sub-assembly step. It uses Unreal Engine, essentially. So it's a pretty complicated thing to do. But that's the funny thing is, like, that's just one small tiny piece of the software that, there's boring stuff like HR management for the factory that we've built in-house, or like batching the kit of parts to different sites at any given point, like which kit of parts to pick up, to batch, trash to pick up from the site, etc.
So before we get too far into like the details, because we're going to dive into this all in super detail later, I think could we take one step back and basically, can you tell us how many homes a factory can build, how many floor plans or whatever are supported by that, and then also just how far along you guys are, because you guys actually have a mobile microfactory. It's not like this is some theoretical future thing. It's happening now. So can you tell us that super high level, what is the scale we're talking about for this thing?
Yeah, I think we should have probably started with an intro in a way. Cuby, we're a full stack hardware software business. We focus in the construction space, mostly single family homes. Eventually we'll evolve to different asset classes, but we design, develop, and deploy mobile microfactories, aka that's our product. That's what we talked about. Those mobile microfactories, they then manufacture and assemble a lot of homes at scale. We've been at this for 4 years now. We're about 350,000 engineering hours into this. These mobile microfactories, they can do about 200 single-family homes a year. The reason why that's relevant, and that number is not impressive. It's the number that's impressive for us is the amount of output relative to the cost to launch a factory. So we've productized the factory, and part of productizing a factory is how can you reduce the capex, so the capital required to launch one of these in any locale, because our business is to replicate, copy, and paste these as many times as possible. But it's the relatively low capex required to launch this. And if we articulate that number, a lot of folks that, especially for manufacturing, sometimes don't believe us. And that number is around 10 million. 0 to 60 full factory launched, and it will spit out about 200 single family homes from foundation to interior finish over the course of a year. And it can do that on a continual basis.
And how expensive is this relative to the legacy technology?
To build a home or to launch a factory?
Per square foot, or however you would normally measure a home's cost.
Yeah, so I think let's take a step back. The reason why we get to reduce costs so significantly, and that's a very important adoption metric, because incumbents, they have no incentive to adopt a new process, new technology, something different if it's not cheaper. So for us, it was vital to go to market knowing that we can build in a very cost-effective way that's, at least at cost parity, but really it needs to be cheaper than existing incumbents. Right now, out of the dollar that it costs to build a home, about 70% in first world countries is associated to skilled labor, meaning human labor hours who happen to be skilled. Because we can debundle from skilled labor, our 70% coefficient goes down by quite a lot. So we can reduce cost by a pretty significant factor. Today in the US, it's about $185 a foot to build a home. We can deliver homes today with a factory nearby at about $100 a foot. So it's a pretty significant cost savings. We're talking about everything included from offsite factory labor to on-site assembly labor to the COGS, so the kit of parts. So basically a home from foundation to interior finish at about $100 a foot.
Totally. I mean, and is that of the $85 of cost reduction or whatever, how much of that is coming from labor savings?
70% of the cost, it's a cost of labor plus subcontractors. We use this portion. It's a standard metric, standard operations that I did a lot of time in other areas. When I begin to use manufacturing lean approach and machinery and the conveyors, we reduce labor force roughly 10 times. And when we reduce the 70%, roughly 10 times, plus we are not using the subcontractors, we'll produce everything ourselves. We produce ourselves windows, glass paints, and so on, and the factory only consumes the raw material, not using other subcontractors. And that's why, well, as Alex explained, that we reduce more than 2 times the self cost, and based on that, in this 80%, $80 that we reduce the cost, well, we reduce it. Not only the skilled labor, we take only the profit from the local vendors who supply windows, glass paints, and so on.
We get to take away someone's margin that otherwise, for example, a window, right? There's a manufacturer, then there's a wholesaler, then there's, a reseller, then there's an installer. So, the window to my right over here, it's been marked up 4 or 5 times before it ever got to the construction site. So there's certain things we also get to produce, some meaningful things that cost a lot, that are a big, consumable in our homes. We try to make ourselves.
I can imagine that this is actually sort of hard to explain to people when you're first doing it, just because there's so much, you're doing all this stuff from there's the software element of you have this super dynamic IKEA instructions that teach someone how to build a house. There's the hardware side, which is the actual factory itself. You're building new machines. You're building this way to churn out parts, put them in pallets, and ship them to a job site. There's even more to. I mean, there's the people side, and like you said, sort of how you're organizing everybody and the way that people are being sent around to different tasks. That sounds different. I mean, I think maybe the simplest way to dive into it a little deeper would be to just sort of break it down into those individual sections. So maybe I would propose we'll see if this actually works out, but I would propose people, process, technology. Let's start by talking about who are the people that are on your job sites. Who are you working with? You mentioned subcontractors, you mentioned GCs earlier. Let's talk about who those people are normally and who they are for you guys. Then we can talk about process, the factory aspect of it. And then let's loop back to technology and talk about more what are those machines in the factory, and what are the magical screwdrivers that you guys are building to make this thing actually work. So if that frame works, let's start with people. In a normal home, normally when a contractor or a general contractor goes out, what does that look like? Do you have to bid on the construction of a home? Are general contractors working with home builders? Let's talk about that.
Yeah. So why don't we explain first what a typical home in the U.S. consists of, how it's built, et cetera? Because I think it's so funny. It's one of those things like electricity, right? People turn on the lights and it just happens. I mean, most folks don't understand what goes into building a home. And obviously that's a really big issue right now, given most of the U.S. I think 50% of the market can't afford a $250,000 home. And we're not building enough of them. There's literally $2 trillion worth of homes that we have to build, which is what we're tapping into. But anyways, when you build a home, there's a lot of stakeholders involved. So for example, you start with a landowner, a developer, or home builder. Generally, let's call it a developer, because I think that's a term that most folks are familiar with. That developer will go acquire a piece of land. Then they have to hire, and why developers are often compared to orchestrators. In an orchestra, what do they call the guy with the one? Yeah, conductor. There you go. So developers are like conductors because they're really orchestrating all the moving pieces. So they have to hire an architect. They eventually have to hire civil engineers, surveyors, then a general contractor who then hires a bunch of subcontractors, everyone from excavators to foundation contractors to carpenters, who frame the house, to electricians, to plumbers, to HVAC technicians, drywall installers, painters. I'm probably missing a bunch, but, basically to build a home, there's these 10 big categories of things that need to happen. And then I think the National Association of Home Builders dives into like the 36 subcategories or so. But the idea is there's so many fragmented moving pieces where it's not like, I guess it's not like if you were to walk into Apple and buy a Mac, right? Like you're buying a Mac, there's a whole suite of software, et cetera. It's a product. Here, you have to orchestrate this entire product, and everyone is misaligned from an incentive perspective. When it comes to, those people, then there's kind of process on top of it. So first, the developer buys a piece of land. They have to secure financing. Then they have to go through a very complicated process of permits and all the different legalities, meaning that an architect eventually has to produce drawing sets, meaning here's what I'm building, here's it compliant with code. They submit it to their local township and they get approvals to physically start constructing. And first you start with site preparation, then you put down the foundation, then you have to frame the home, then you have to install all the systems, so electrical, plumbing, HVAC, etc. Then you have to insulate, put in the drywall, paint the drywall. Then you have to do exterior, interior finishes, right? Like cabinets and the appliances and the lighting, etc. And all throughout that process, you have inspectors that are showing up to essentially check boxes saying this is legally allowed or, hey, you need to fix this. Once that's done, you get a final inspection, and then you TCO the home, meaning you get certificate of occupancy, and then end user can go live in that home. All of that takes 9 to 14 months. Right now, it takes literally a dozen plus people. It's hard to build a home, and there's a lot of moving pieces. That's a typical home, and it's very expensive today.
So just before who are the people that are building that basically? Like who are like the home builders in that scenario? Is it how is a home builder different than a general contractor, different from like the subcontractors?
For me, it's weird because I come from commercial real estate, and commercial real estate, the developer is always the person taking the most risk, orchestrating the pieces. And home building ecosystem, if you think about like a Lennar, who's one of the top largest home builders in the U.S., or the G.R. Horton, or Toll Brothers, folks might know those names. They're publicly traded. Their stocks have done really well despite interest rates. Basically, home builders, essentially, they're never the group that's actually building. They're the developer. So home builder is synonymous with a developer. These home builders hire general contractors locally because a lot of them, at least the big ones, they operate on a national scale. There's no way they have general contracting ability in every market. Therefore, they have to hire a local group that oversees the construction, who hires all these third parties that oversee all these sub general contracting work. But home builder, different from general contractor. General contractor is who physically builds the home. What we replace and where we come in is we are a tool for home builders, but we serve the function of a general contractor and all the subcontractors. We replace that entire equation. So we are a turnkey solution for a home builder that gives us their plans. Once they get that permit-ready legality to build, we step in and build the home, or the factory does that's nearby.
Got it. And maybe this is the right time to talk about sort of the demographic problem and, who are the people that are, at the end of the day, like who are the people that are on the job site, like actually doing the thing and, hammering things and installing things. Like, do you want to talk about who that normally would be and talk about the skilled labor stuff, but then also talk about who can do it for y'all?
We obviously look very different. Oleg actually hates when we get called a construction company because we want to be and look like, and everything we do is more akin to manufacturing. And that's important because it also translates to the type of people we hire and use, et cetera. In traditional construction today, a construction worker is exactly what you'd picture a construction worker to be. And ironically, given that, the sphere of work that all of us here are on, I guarantee that like you, Christian, don't know a single construction worker. You don't even have a third cousin that's a construction worker. I, for sure, living in New York City, don't know a single construction worker. All my friends don't know a single construction worker, et cetera. That's exactly what's happening is there's no incentive these days, and no one wants to be a construction worker. It's a physical industry. It's very labor intensive. It's not the best working conditions. It's prone to injury risk, et cetera. You don't age well into this industry. However, today, the average construction worker is 40 to 50 years old. Kind of scary to think about, considering that almost 40% of the workforce in construction is going to retire in the next 10 years. So who's going to build America? Who's going to build the homes we need, the buildings, the bridges, etc.? So it's a big problem. And for every 7 folks that now retire, only 1 replaces them. So solutions like ours need to exist. Venture is very excited to back solutions in this space, mainly because you have this massive, most vital sector to any economy in every country is construction, but you have a very depleting workforce. How do you go build what you need to build? So it's least amount of efficiency, massive TAM. Venture and investors get pretty excited, but it's hard. So we replaced that typical skilled laborer that exists to go do the pieces of the construction process and replace them with unskilled labor. So we can hire, the same worker that Amazon hires in their warehouse, or even a barista from Starbucks. Given that there's different stages to who we train, who the workers are, we basically get to use unskilled labor.
I can add why, I don't like when Alex explained us as the construction companies. Well, 50% of the guys, they're engineers who is working in Cuby, their main motivation, they want to destroy the construction industry, because each of them build a home with the construction workers. He do the renovation of his house, something like that. And that's why they feel all the pain in the industry, and they understand that the industry is totally dysfunctional in comparison with manufacturing, because the process is different. And also the quality of the job is very low in the construction everywhere, because, the quality of toilets, the quality of, the tools that they use, the uniforms or something like that is not hard people to go to the construction industry, and we want to change it. Because in our Cuby, in construction, on the construction side, we have a separate, 2 ship containers where there's locker, shower, bathroom, all the tools, everything. And, well, me personally, sometimes I go to the construction site and I work myself in the stages, because I need to feel everything myself. And that's why when I work there, I feel myself much better, because the environment that we create for the construction workers in the factory and the construction site is the same as in the office. And they have no difference to work in the office on the construction side. And that's why we additionally, do the additional motivation to work in Cuby.
Using Strata makes all of your identity tools stronger, connecting any app with any service that you want to use. Strata's identity orchestration platform separates the identity logic from your applications, so you can optimize existing IAM tools and manage them from a single control plane. So in short, building an identity fabric with Strata will allow you to secure non-standard legacy apps, keep your complex access policies, retire outdated identity providers, and get everything done in record time. Visit strata.io/firstprinciples and get a free pair of AirPods Pro when you share your identity priorities with the Strata team. Connect today at strata.io/firstprinciples. Let's get back to the show.
So what does the process of recruiting people to be on your job site look like versus recruiting somebody to be on a normal job site? I imagine that with unskilled labor, it's much simpler.
So we have to think of it this way. The reason why we wanted to localize manufacturing is because you literally put your finger on a map anywhere in the US, there's thousands of homes that need to be built. Our thesis is lower CapEx, good output of manufacturing, meaning we only need 200 homes a year to be incredibly profitable per factory, incredibly profitable. And you pick any dot on the map, there's demand for it, especially if we can undercut the market in terms of cost. When it comes to a full capacity factory, we're employing about 260 people per factory. There's 35 folks in 2 shifts on the on the factory floor. So each mobile micro factory. And then there's, say, 20 construction sites happening within a 150-mile radius. There's 4 unskilled folks in 2 shifts per construction site. That's another 160. So 35 times 2 shifts plus 4 times 20 times 2, it's another 160. So the delta between 260 and the summation of those two numbers is really the just regular G&A of like janitors, like supply person, management of the factory, etc. But all in all, 260 people to produce 200 homes a year. It's actually really favorable, and given those are mostly unskilled, it's much easier to recruit.
And you guys actually have part of that as part of your process, though, right? Like if there was a person who's setting up a factory, you've also extended this like here are the steps in like a very easy way. You've extended that system to also even including like recruiting, right?
We have an entire HR system in the OS, hiring, training that person, payroll, all built in. Like we didn't API with like Rippling or something. We built it all in-house. It's relatively simple, but it just works so much better when it's for our purposes. So yeah, that's all in-house.
Okay, let me humor me. I think that there are sort of like in my head, there are two sort of models for how you might build a tech company in terms of the people you're selling your product to. Number one is the Amazon Death Star model, where basically like you take everything, you try to build the perfect, you not only try to build the distribution system, but you also like build your own products that you eventually sell to the end customers, and you're really taking it like totally end to end. Like, yeah, you know, whatever, Amazon Basics is now taking how much volume of like people buying soap, people buying like all the basics, like that sort of thing. So there's an Amazon like Death Star model on one side. On the other side is like the Arm the Rebels Shopify model, where they're not trying to be the one store themselves. They're not trying to, you know, replace everything you've ever done. Instead, they are trying to do, basically, they're just trying to make it so that other stores can be more successful and giving them the tools they need to succeed. So on one end, Death Star, do it all yourself, end to end. On the other end, Shopify, Arm the Rebels, help people that are already doing these jobs do the jobs better. Would you guys describe yourselves more as like the Amazon of home building or the Shopify of home building?
I think it depends on point in time. So I think we have kind of like a 3-tiered master plan. It's going to take 10 years, maybe more. But the way we think about it today is it's all like, imagine there's a master plan and it's like a timeline. That timeline is highly correlated to the right cost of capital. That's very important to us. So our initial go-to-market, our customer is really anyone that we white label a factory to, meaning our customer is anyone we partner with to launch a factory, meaning it's not our factory, we basically license it. So kind of looks more like McDonald's today, if you think about it that way. With time, as cost of capital for us gets cheaper and cheaper, meaning we go away from venture, more towards project financing, debt, equipment leasing, etc., we want to be able to own the factory ourselves, and its customers are small to medium-sized home builders locally. So we want to capture all the revenue, all the GMV. And then eventually we have other verticals that we get into, which is an entire materials supplier arm. We want to supply materials to the factories, everything from kitchen cabinets all the way to, you know, certain chemical composites for our pier panels. Then we want to launch our own home builder, you know, as part of phase 3. So eventually, not only are we helping small to medium-sized home builders, we'll also at the same time be competing with them. However, Cuby will be able to reinvest into marketing a lot more than any of the top 20 national home builders today. So eventually, we want to launch a brand, eventually. But it all happens in a tiered way. Right now, the goal is like, get as many factories out into the market as possible to basically iterate via Kaizen, right? Process improvement the whole time. And yeah, so like it's hard. Today, Shopify, eventually probably Amazon. That's the right way to think about it.
That makes sense.
Oleg has always, since day one, pitched this vision, and like it's always been hard to investors because like it's already hard to explain our business. It's so
multifaceted,
there's so much fit in. Exactly, that, you know, explaining to them that eventually we want someone to, like Christian and his family, will go on like a simulator essentially within the confines of their local code, be able to put together a home, pay for it. It gets sent to the local factory to be produced, and someone else installs it, like even a third party.
Automatically take a loan and build it there. And I can additionally add to my dream that as we have a software that control unskilled labor and give them an exact task what to do, when the humanoids will be ready, we can use them because we already know what to do. We need to task them and so on. And I think that in 10 years, when everything will be ready to do that, we'll be the first who will use humanoids in the construction.
Wow.
Because we have a software how to
Makes
do that.
sense.
Well, we're already built for it. The entire process is digital twins, so theoretically that's an upload to a humanoid, but humanoids are not capable yet, obviously, to execute on what we need. So, Christian, one of the things we've realized is kind of tough in this space. So, industrialized construction, right? It can take many different forms. We're just one form of it, and we believe in our thesis. We think the bets we're making are correct because they're translating to cost and us executing on homes. But a lot of folks preach automation in the space. We think automation day one is not a correct thought, just because if you look at Tesla, the reason why Tesla has been able to automate so much is because they benefited for, you know, almost half a century of Toyota's production system and constant improvements around, you know, debundling from skilled labor, making humans more efficient, etc. Construction never had their Toyota production system phase yet. So how can you automate? You might be going in the wrong direction. There are certain things that you don't even know what you're automating. So we're big believers in being able to make humans more efficient first before we automate. I think out of our 15 stations, only 2 are semi-automated at this point, with eventual thought process that eventually each station gets automated.
Okay, this is actually a really good tie-in. So we talked about people and like who is building the homes and, you know, who are you selling to and that sort of thing. I think it's now good. Let's move over to process. So maybe to set off this section, can you talk about the diversity of homes that you'll be able to build just like right away? Like, are you starting every home is exactly the same, we're just going to copy and paste it a million times, or are you already introducing that variability into like the actual final homes that are being output from your factories?
It's day one, and that's a very important principle. Lack of customization in the space has been lack of adoption. And like maybe you can talk through the base kit of parts and then the permutations. I think that's good for you to tackle.
The technology for sure have some restrictions. It's not, have some variety of design like a ordered standard construction. But at the same time, we have less, restriction with a modular construction because we have a panelized system. We're producing panels, part of the frame. It's like a columns. It's like a electric stuff. It's something like a kit of parts. And using them, we can do a different variety of design. Plus, have 3 external finishes, 2 internal finishes. And based on that, we have also a lot of designs that we can use. Based on the technology, we have a grid, 10 feet on 10 feet. And based on that, the plans can be different. External plans, internal plans also can be absolute. That's why right now we have a software where our engineers very fast, or architectural guys, very fast do the design of the house, push the button, and the system automatically recalculate the exact price because we exactly know how much kit of parts and what kit of parts we use, how much man hours we need to assemble and to produce it, and to choose different type of finishes, like in a game. We also can change the view of design and so on. After that, push the button and the system in Unreal Engine automatically generate rendering, plans, video, instruction, how you can walk around the house and so on.
It's so like mind-blowing sort of that you'd be able to do that. Like, can you talk about just basically the one step deeper of like what is doing that generation and what is doing that like work planning or whatever? Like maybe let's just focus on the work planning piece of it. Like how do you design a system that knows how to build a home and then knows that this step has to go before that step and knows that you're not accidentally missing a screw somewhere?
Well, I can start and Alex will finish. You know that to solve very complicated problem, you can divide it on numbers of very simple problems. And when you solve each simple problems, you can solve the big problem. We do the same in the construction. All of the process of the construction, we share on very simple operation, repeatable simple operation. And with unskilled labor, we solve each operation step by step. And the guys even don't know what they will do tomorrow because they know what they need to do now. And the software orchestrated it.
Does that mean that you have to, at the base level, like when you're designing this and you have your engineers working in your R&D center, you have to define a set of like primitives, basically, like plug thing into other thing or like screw in screw. Okay.
All the instruction and so on, and we put them into the software and orchestrate them based on that. That's why, and the beauty of, or maybe it's not the beauty of this stuff, if we will change something in this scenario, kit of parts, at the same time, we need to change the software, machines,
right,
and the process. And that's why
it's also integrated. It's all,
think about it. Exactly. All of that is integrated.
I think I can actually explain it even simpler. So think of our process, meaning from raw input to finished goods to assembly as a multivariate equation. It's multivariate because there's different raw inputs, different finished inputs, different finished goods, what you need to do with them, how you package them, who does it, and then on-site, right? So when you have a baseline, that baseline has, say, hundreds of iterations of combinations, right, of steps. It's all about just orchestrating the steps. And the hard part is, let me explain the hard part. The hard part is knowing when to push and pull, basically, because it's not, again, You're not building one home. There's a person in the factory who, everyone gets a phone. It says, go to station 26A, do this task. That person is not always only doing that task. That person is constantly being distributed across different tasks. That's the hard part of like knowing when to pull and push for just-in-time manufacturing here. So it's like the baseline software is distributing process based on set parameters of raw inputs.
What do you mean by pull and push?
At any given point, right, there's different stages to a home. It's not like you're producing the entire home in one inning. You're basically producing for the 20 different homes happening around the factory, you're producing a different stage for each of those homes. A push and pull being just-in-time manufacturing, essentially, but for the 20 different homes.
Yeah, I can explain to you. For example, we need to use this pen to do the stage number 1. And we need to use these earphones for the stage number 2, and this one for the stage number 3. The system have on the warehouse near the construction site these two things. They're doing that like that. When the guys taking this pen and begin to assemble it, the system give task to the factory that they need to produce this one and deliver it. And that's why this is non-stop pulling system, and the system give the task and pull necessary kit of parts to assemble on the construction site, plus what they need to produce.
Part of the mobile microfactory isn't just because of the first principles, let's close the feedback loop between offsite process from some gigafactory and onsite. It's also economical in the sense that we don't need to store, tons of materials on site that you have to pre-buy, right? Those are massive fixed costs, or I guess variable costs, but upfront. We don't have fixed costs like rent, because otherwise we would have needed to rent an Amazon warehouse that's, several $1 million a year as a fixed cost. We rent a parking lot that's less than 1% of the P&L of the factory. So it's things like that are economical for a mobile microfactory, not just from a first principles practicality of like making it work.
From a first principles perspective, I feel like the pro of just in time is obviously lowering the capital burden. Like, you don't have to have as much stuff in inventory. You can just pull things in when you need them, and then they're immediately out in the factory. And the amount of time that they spend in the system is relatively low from you buy them to they actually are deployed. But the trade-off for that, in my mind, is variability, or like risk of not having those original inputs to do. Like, in theory, you buy them exactly the day that they're going to be put into the machine, and then they get sent out the next day. But all of a sudden, there's a shipping delay of 3 days, and then the whole thing sort of breaks down. So are there ways that you're solving for the variability problem with the just-in-time manufacturing?
Yeah, it's called Kanban. Do you know that just-in-time, it's only one of the 14 principles of lean manufacturing. We use all 14 in our process. And another principles is to use Kanban. Kanban, this is a minimum level of materials that you need to store and this minimum level is determined by the process itself. For example, if your supplier need to have 1 month just to deliver to you, all of these materials, and you will use, this amount in 1 month, you need to have in warehouse two months material. And that's why all of these levels is control. And we have final numbers of these materials that control on the factory. We have a special shelving for that and so on with Kanban card. Again, if you want, I can show you one of them. I'm right now.
Christian, while Oleg is walking, the other layer to this, remember I told you the second big bet is around familiarity? The reason why familiarity matters in this case is none of our supply chain is proprietary. Imagine that day we didn't get cheaper sheetrock from China. We go to Home Depot, not a problem. So the material selection is very important here. We need it to be locally available in any market we launch. Very, very important. Part of that is because of what you're saying.
First of all, this is a design center where the mechanical engineering is seen. This is technological guys who is doing the software for CNC machines, and this is a test manufacturer where we produce machines and kit of parts, and I will show to you how the machines look like. For example, this is a robot for screw pile foundation who produces screw piles. This is a storage for the aluminum composite. This is, for example, the storage that we also produce to use light beads. Or, for example, this is also the storage for the gas. And in this storage, you can see this is a Kanban card. In this Kanban card, this is the minimum amount that you need to use and the order. And this minimum order is controlled by the quality of the suppliers that can supply for us the gas. or something like that. And this is also to control. That's why we're producing not only machines, we need to produce also such kind of stuff like that with the Kanban cards, with everything, and so on. That's why the system itself, it's not only the machines, it's also the shelving, it's tooling, it's how to take it, how to deliver it, how to control it. And only producing that, you can increase the production capacity.
How much? So I imagine that there's one part of this that's like you design the factory to be the platonic ideal of what the factory could be, right? Like you have all of your, for example, just very specifically, you have your Kanban quantities that are defined based on some formula, like lead time of part or to, how much we have to buy, whatever it is. But then I imagine there's another piece of this is that you actually go build some homes in the real world. And once you go build some homes in the real world, you realize that your factory is not the platonic ideal of a factory, that there is something out there that causes inefficiencies or causes like weird variable changes or whatever. How do you measure that? And then have you already done that? Have you already found some stuff that is not ideal but actually makes your system output better at the end?
So all the time we're spending like thousands of hours on a machine, and then in real world, you start hiring unskilled labor to test it and it's just not working the way you want it. You throw that in the trash and you restart. We've also started building homes around their first test mobile microfactory. We're constantly learning there. An example, sheetrock, like the wall behind you, right? It gets literally like nailed into place on your framing. Then they'll plaster it and then they'll sand it. Then they'll paint it twice. That is the most horrible bane to our existence because it makes the construction site dirty. It's very slow. So we actually found a solution for that. We no longer will be, as a finish, just painting sheetrock. And we won't talk about yet what we're doing, but something very clever. But like things like that, you discover in practice took too long, too many labor hours. You still needed to bring in skilled labor. There was mistakes, but the way the system was designed is, and I think where a lot of industrialized construction has gone wrong, they all assumed exactly what you're assuming. You create some panel with MEP in it, you bring it on site, it perfectly clicks together. But the truth is, with every iteration of stage, you're getting further and further, you're getting more into territory of uncertainty, right? Oleg accounted for widening uncertainty in the system. That's why it's a pretty flexible and dynamic system in itself. And Oleg, you can probably cover this more than I can, but...
Well, I can answer on your question, Christian. It's also one of the principles of lean manufacturing. It's called Kaizen. Kaizen, it's a process of non-stop development and improvement of the process. And that's why when we begin to do the real work and real stuff, for sure, we amend all of this shelving, all of this machine, the process, and so on. And that's why we open our own test factory where we test all of that stuff. And after the second, the third, or the fourth, for sure, the process will be polishing more and more and more. And this is beauty. You know that in lean manufacturing approach, when the lean manufacturing consultant come to the manufacturing and he see a lot of job, he feels himself good because he can change something. When the process in the manufacturing is so polished that you can change everything, you have no job. That's why, for sure, all of the process that we are doing in the factory, it's a Kaizen, and for sure, we will improve our process.
To be really specific about it, like how are you capturing that sort of efficiency data, though? Like, do you have because I imagine that this is a benefit for you guys. Like, if you know what step everybody's on, you're like, oh, we thought that was going to take 2 minutes. It turned out it took 10 minutes. Why?
Oleg spent an entire weekend 2 weekends ago just trying to quantify and create KPIs around stages. Part of the reason why we removed sheetrock is because it's an objective finished job. Did you paint that well or not well? It's still painted, right? You can't measure that. So that's why we have to remove all jobs that can't be quantified.
And as I explained to you that each part that we produce, we exactly know such kind of metric, like how much material we spend and how much it costs, how many man hours we need to use to produce it, and how many man hours we need to assemble it. That's why when we produce right now houses, we check all of these metrics and we improve them. And that's why as less hours, for example, to produce this stuff, we need 1 hour and 1 hour to install it. When we change a little bit the process, right now it's half an hour plus half an hour. That's why we improve the process and we reduce the cost. This is one of the main metrics that we control, how many man hours we spend to assemble and to produce.
Very cool. Okay, I want to shift this again from, okay, we've talked about process, we talked about people. Let's talk about the tech a little bit more. So I'm curious to hear, I don't know how much of this is open to talk about or whatever. But what are those machines? Like, what are the things that you've built in the factories that are new and different, and you guys had to build yourselves because you couldn't find anywhere else?
There is a lot of robots that do a lot of job. For example, like we use the standard welding robots, but we produce the tooling for them. And because this tooling is 100% fit only for our, proprietary parts. We are producing the machines that producing the panels. It's a sandwich panels with at the same time milling, freezing, and so on. That's why it's more complicated. But at the same time, when we look on the factory, our factory, it's a bunch of small factories. Each of them produce separate parts. For example, there is a department that produce glass paints on the windows, and there is a lot of machines that do that. For sure, we can separately produce windows and can sell it. But for us, it's not a goal. For us, the goal is to produce windows only for our own, houses for the project, because we need to do it just in time. For example, the other department producing screw pile foundation, the same stuff and so on. That's why, just for you to explain what machines we did and what not, that does not exist in the market, I will be happy if all of the machine will be in the market and we can buy it. That's why we will reduce a lot of our time. But it's not existence. That's why we need to design it to produce it.
Christian, our goal is to get from A to B in the simplest path possible. B being, 275 mobile microfactories. A being kind of, we got to produce everything ourselves. We can get to A to B in the simplest path possible while being cost effective. That matters too. Some machines are out in the market, but they're too expensive. So we said, we'll just do it ourselves.
For example, the structure of the factory itself. We have a panel, we have a ship containers, all of the machines we put into the ship containers ready to start. And we put the inflated building on it that I showed you in our R&D center. We have the same. It's also one of our inventions. But without it, we need to compete with Amazon to open 275 factories in the US. That's why it's our, way how we can scale the business.
So how do you make the decision about, I imagine, for instance, like you're not building your own doorknobs or something in-house, but you are building your own glass. Like why?
I know the glass, I can explain you why. Doors, you use only one size, and you can use the one size of the doors in the building. That's why you can buy it and you can have it on your warehouse. Preventing the glass, you have 10 or 15 types of the glass things, and you need to hire the local factories that will produce windows for you. And as it is a non-stop, just-in-time process, we're not using subcontractor, because when we will begin to use the subcontractors, this guy will 100% fail, and they will not supply to you this windows just in time. It's 100% because they have their own problem, they have their own production capacity and so on, and our conveyor will stop. And that's why, not to stop the conveyor, we use only raw material, and one of the main principles, what we produce and what not, for us, can we store it in our warehouse or not? If we can, we will buy it. If we cannot do that, we will produce.
To add to that, it's actually more simple than that even. So any finishing for the house, think like, things like lighting or cabinetry where, like kitchens or appliances or like doorknobs, you said. So what quantifies as finishes, we generally buy from the market, but we might prep it in some capacity in the factory, but we don't make it. Everything else, like the foundation of a house, the walls of a house, like real structural, like what is a home without the finishes, we mainly make that ourselves.
Got it. So, but the things in principle that you would want to bring in-house are things that are, there's not easy, like commoditized supply chains for, that are, you would want to bring it in-house if it's more custom, like there's more variability in it, as opposed to just like, okay, a doorknob is a doorknob is a doorknob.
Well, plus something like a doorknob has been so mass produced and there's so many suppliers that it's very hard for us to, it's not worth the ROI to go build a station, increase the size of our factory, employ the folks to do it. Like we can just buy that from China, 7x the cost reduction versus Home Depot.
And additional stuff, why we make a decision to produce, if on this product where the manufacturer have big margin, for sure we'll do it ourselves and take this margin ourselves.
Totally. So if it's more down to like the actual metal cost of the doorknob. That would, if doorknobs cost $100, you guys would definitely make doorknobs. But because they're so cheap, it's like, why not?
The other practical reason is like warranties, right? When we buy it from someone, we're covered by their warranty. When there's things like windows we have to make or non-structural wall panels, we then have to provide the warranty and have to get certification to produce those things. So the more you do that, the more complex it becomes.
All right, I'm just going to lob a softball into the air, and you guys are going to just like hit it out of the park. Why not just 3D print all this stuff?
There's different forms to industrialize construction. I think out of the three forms that exist, there's volumetric modular. If any of your viewers have ever stayed in, maybe student housing, maybe Citizen M hotels. It's a chain of hotels across Europe, right? Many of them in the US. One just opened up in Silicon Valley, I think. Volumetric modular, the idea is you have some sort of gigafactory. It's, $50 to $200 million, and it produces entire rooms off-site, like a finished room, finished kitchen, living room, etc. And you end up shipping basically volumetric boxes, shipping air, thousands of miles, and then someone else has to go assemble it, stack them on top, etc. That's volumetric modular. Prefab is really, there's different notions to prefab, but that's really where we get categorized, although we're really more like traditional construction meets prefab. But prefab, the idea is you produce maybe wall panels that have MEP in them, or some parts of a home, maybe all parts or some parts of a home, ship them thousands of miles, put them together on site. And then there's 3D printing, which is like the full 180 other side of the spectrum. 3D printing, I think, is an interesting solution that venture has gotten incredibly excited about. I think it's going to be a very long time before it works. And when I say works, remember, the goal is we got to produce literally millions of homes in the US. There's, in our opinion, some issues to 3D printing. Those issues are around, A, you can't build bigger than the 3D printer. B, it's very unfamiliar. It's very hard to create adoption in the space when you have so much unfamiliarity. I mean, 3D printing is just like alien compared to traditional construction. Not cost effective today, and mainly because it's just 10% of the home building process. 3D printing solves for framing. You frame a house. Everything else, 90% of the build is still done by that missing skilled labor. Traditionally, the interior finishes, foundation, plumbing, MEP, etc. So we don't see 3D printing as the solution to solve America's housing crisis.
Perfect. Home run. I think one question that I have on the sort of like tech side, I guess, is like, I mean, at least the way it sounds to me is that a lot of the things are built now, right? Like you guys have homes that are coming out of the factory. Like you have the system in place. You have the Kaizen cards that you showed me. Like it's all sort of there. I mean, do you guys have like a V2 that's somehow going to make this like 10 times better in the future? Or is the main thing that you guys have to go do now just like basically finance this, build a ton of homes, prove that it works, get the debt financing thing going, like lower your cost of capital?
So part of the reason why we're somewhat unique, and you obviously spend a lot of time in deep tech, and that happens to be at, say, 100% of your network at this point. The reason why we're unique in deep tech is because we've been able to arbitrage some of the technical de-risking with Eastern Europe, where engineers are 10x less, where Ola gets to spend a bunch of his time, where we set up manufacturing and R&D. And we didn't need to raise hundreds of millions of dollars to get to this point. We've done quite a lot of this with very surprising amount of capital, to the point where we've now de-risked probably 98% of any of the technical risk associated with the business. None of this is R&D anymore. All of this has been tested. I mean, of course, there's constant improvement. We're going to market with what we call VEEP 1.2, which is our factory associated with single-family homes. Everything going forward in the capital will be raising in the future is all around execution, operational risk, and constantly driving away from venture toward debt. But yes, we've launched, tested what we needed. Now we're actually starting to commercialize, and we're starting to sign contracts. Anything beyond this, we do have a V2 and a V3 version of the factory, but those are tied to different asset classes. So right now we're focused on detached single-family homes, 1-story, 2-story, basement, etc., but single-family detached homes. We want to head toward multifamily eventually, and then to other asset classes. Every other asset class except industrial. The column widths for industrial don't work for us.
What does that mean? What do you mean by column width?
Warehouses are big buckets of space, so where the structural columns are to sustain the roof, they're too far apart where our system can physically manufacture the size of panels and stuff. So if we just stay in single family homes alone, that is a massive, massive piece of the market. It's almost 50% of the US construction market. We can stay here for many years. Other cool thing about our factories is because it itself is a modular factory, each station can be upgraded. So there's a station, you literally just take out a container and plug in like a new window making station that's more efficient. So you can upgrade with time. So that's why V1.2 eventually, the same owner of that factory can get to V1.13 because they get upgrade essentially.
In developing of any process, of any product, there is a KPI. It's called TRL. It's technical readiness level. It's a NASA methodology. Based on the TRL, right now we are TRL number 8 because we are testing right now in mass production, and our goal for the next 1 or 2 years to open 2 factories. Because one of them we tested TRL 7. Now we open the TRL 8 and we begin to earn money in scale. And after that, it's our scaling. It's TRL 9 when we must produce these factories and begin to scale the business.
So, it does sound like the technical piece of it is like very far along. I mean, I imagine you guys are getting a bunch of folks like home builders reaching out to you saying like, hey, we want to do this, or maybe even developers, like people who have lands. Like, can you talk a little bit about who are those customers, who's reaching out to you guys, like what sort of commercial traction you guys have so far?
Yeah, so we have to go pretty slow right now. Our goal is to move mass manufacturing to China. So we want to we've now taken all our designs of machines. We know what our factory's blueprint is, how to mass manufacture it. Now we can give it to someone else to mass manufacture. So post this fundraise that we're doing now, we're going to launch a pop-up factory in China, operations there to basically do up to 8 factories a year. And then that will scale up to 20 factories per year, meaning all the machine building assembly, we shove the machines into containers, package that factory and send it anywhere in the world to be launched. However, right now we have to still go really, really slow. So we've signed one really big contract in the West Coast with a partner that we're launching a factory of. We have 2 more in the works, also in the US. And I think we're going to go pretty slow from that point on. But because we've productized the factory and we've gone now, at least for a long time, we've been quiet and now we're actually pretty public about what we're doing. We're constantly getting inbound from folks that are like, wow, I could own this in my market. I know there's a housing crisis. I know it's really inefficient to build. And the gamut of folks we get reaching out, there's a range. We get folks that want to be partners that are like a small builder that says, hey, if I call a bunch of friends, how much would I need to put one of these up? We get folks that are massive general contractors in a region. We get ultra high net worth family offices that are like, wow, now's the cyclical time in the market to own a manufacturing business. We get PE shops that do manufacturing industrial investments. So it's a whole gamut of folks. But generally, the folks we're most effective and helpful for is anyone that wants to launch a factory who also has a ton of acreage that they were going to unlock anyways via traditional home building process. But yes, we're basically putting folks in a queue right now. We want to be everywhere, and we want 275 factories out there.
That's so much volume. Like once you actually have like almost 300 factories out there, they're producing 200 homes a year. That's like a ridiculous amount of scale. Like, I mean, and so here's one thing about the Astranis business that I actually really like. So Astranis builds satellites. Each of those satellites is itself a contained project. It's like we don't depend. Like the success of one satellite has nothing to do with the success of another one. Like this one might have 100% utilization. It's like fully like up to scale. And this other one has 20%. Like that's not going to happen. They're all going to be 100%. But you get the point. They're all independent. And I think that's actually a pretty cool thing about your product as well. It's like you're building these factories. The factory utilization of one factory has nothing to do with the utilization of another factory. I mean, they're independent projects that presumably could be independently financed too.
They are. And just like you have a dashboard covering all these different satellites and their performance. Our goal is also that a lot of our corporate gets split over multiple factories, essentially, where we can oversee from our HQ kind of the performance, which machine went offline, et cetera, across all these factories. And yes, it's hard to imagine 275 factories, but not when you've been thinking about it like that from day zero.
Totally. Yeah, you guys are building for that. It's not like you're building just one factory or just one home. You're building for mass automation, like factory line stuff. Okay, do you want to talk a little bit about about like you guys are fundraising right now, right? So if people are interested in being part of the future of manufacturing, then they should reach out to you.
Yeah, most of the folks we spend time with are very technical, deep tech investors. We're building a complicated business. A lot of folks we spend time with, including our last investor who led our round, was a climate tech fund. there's a massive climate tech angle here that we rarely talk about just because we believe economics should drive everything. Sustainability should be a byproduct. It should be just something you do anyways. But climate spends a lot of time with us, just given that construction is one of the biggest polluters out there. There's so much waste associated with constructing, so inefficient, etc. We've raised a lot less than people think we've raised, just given everything we've done. We're now raising something a bit bigger, and it'll probably be the last equity we ever raise, because everything going forward should be debt. And I think you guys are pretty comfortable, especially in your business, understanding where project financing and equipment leasing and really the right cost of capital steps in. So our goal is to do this last raise, prove this out a bit more, and then everything going forward, I mean, what we do is very financeable. It's just manufacturing.
Are there specific milestones you guys are trying to hit with this fundraise?
Yeah. So a lot of this is to help execute on our existing contracts. A lot of this is to set up this mass manufacturing facility, what we call the Papa Factory, that births all these mobile micro factories. It's to keep producing case studies. It's to also produce, I mean, no one gives us enough credit for a first of a kind mobile micro factory in Eastern Europe. So we have to go launch our own now, likely in Texas, using some of these proceeds. So hopefully after this round, we get to do a lot of damage out there in a good way.
Awesome. Any sort of final words for our audience? Places you want them to go, things you want them to check out, books you want them to read, Oleg?
For sure, I will be glad if you read my book. The last stuff that I want to mention in that we're waiting everybody is a construction worker in Cuby in future.
There we go. Nice. Even I will be able to build a home with the help of Cuby.
No, I appreciate it. I think our website is good. It's just www.cubytechnologies.com.
Well, thank you guys both so much for being on. This was awesome.